Hello, hello. Welcome again. Welcome to my YouTube channel. I'm going to take you through the improper integral. I'm going to take you through the improper integrals. We want to find the improbability of the interval. So we want to find what is an improper integral. So in case given given that you have integral of a to b fx of dx, where f must be bounded and finite on AB, where the fx must be bounded and finite to this AB, to this limits AB. So i.e. that is, if we have a graph, if we have a graph if we have a graph so that is a graph of f of x, so then you are given this is a, then it ends as b at b, then we say it is finite. It is finite. But there's some, but if we have a graph like this, if we have a graph like this, suppose we have a graph like this, this is x, and we have the limits there, and it does not I want to look at this. Then we have another limit coming, another limit coming, then we have another limit coming. So this, so this means, in this case, it means that f of x is not bounded, where f of x, this is f of x. If you look in this diagram one, our x was bounded through this through this region, was bonded through this region, region Y, it was bonded through region Y. So let us so let us do it by an example. So an example, if given example 1, given that integral of 1 to infinity equal to 1, f of x is 1, s raised to power x raised to power 2 dx. Then if you look at the function, our integral, this function is not a finite because it does not stop. It is not a finite. So I want to know that for a function to be finite, it must have a certain limit, a certain range. But this one, the function not finite because it's not finite because it is not finite because it does not stop. It does not stop. So consider. So what is the solution? So solution. This graph is of this. This graph is of this. Why? This graph is of this. Example. Is of this example of this graph. This function is of this graph where y is equal to 1 over f of x. It does not. It ends at the infinity. So it ends at the infinity. So the function, the integral of 1 to b, if you find this one to be in order, it will be x negative 2 dx. X negative 2 is the same as this one, just the inverse, dx, which is equal to 1 to b is the same as that one dx. So it's the same as that one dx. So find the integral of this one. Find the integral of the same thing. So it will be x negative 1 divided by negative 1 integrated from 1 to b. This will be the same as negative 1 over x, negative 1 over x 1, then b. From b, from 1 to b. What will be the solution? So from 1 to b. So what will be the solution? What will be the answer? Answer will be, so we will get that so we'll get that -1 divided by b minus -1 divided by 1, which will be equal to will be equal to -1 divided by b plus 1. So if you find the limit if you so if this is the integral, if this one is the integral of the function, the solution is the integral of the function, let us get the limit. So what is its limit? So limit of b tends to infinity have -1 b plus 1 will be, if it tends to negative infinity, so it will be -1 divided by that b is the infinity. We substitute each and every in b with the infinity plus 1. The answer will be, this one will turn to be 0, then the answer is 1. So means this one, means that the function, that the function means that the function of 1 to b, not 1 to b, 1 to infinity 1 all over x square dx is not finite. Look at the example 2. Let's look at the example 2. If we are given a function as 1 infinity. Another second example, if you're given 1, or if you are given 1 to infinity, then 3 all over x dx. So we say that this is a divergent function. But if given function like this, where a tends to negative infinity, 3 all over x dx, this is a convergent function. It's a convergent, that is a convergent function. That's a convergent function. So let us find our function. Let us find our function of the divergent. So if given like this, means our limit of b tends to infinity. Our limit of b tends to infinity with 3 over x dx. This is 1 to b will be equal to limit of b limit of b, limit of b. This one was 1 all over n, so 1 all over x, and this was 1 all over x, and you know 1 all over x, 1 all over x is ln of x, so it was 3 ln of x, then use from 1 to b, substitute it from 1, substitute it from 1 to b. How will you substitute it from 1 to b? How will you substitute it? So this one, it is limit from b tends to infinity 3 ln b minus limit of b tends to infinity of 3 ln 1. So this will be the same as that one. The limit will be the same as, so our answer, make sure you write your limit well. Our answer will be limit of b tends to infinity, 3 ln b, which is ln b, which is, if you substitute, you'll get positive infinity. This is a divergent. Divergent means it grows larger and larger. Convergent means it goes slow, lower, means negative infinity. Is this negative infinity? So that is our example. So so guys, that one, that was the improper integrals. That's how we find the improbability of the integrals. So remember to subscribe, like, share, and comment on how. If you have questions, post them on the comment section. Those questions, post them. We will tackle them and make mathematics easier. Do not forget to share. Remember, I love you all, and I also do domestic teaching. Domestic teaching wherever you are in Nairobi or everywhere or anywhere. So let us make mathematics easier for our children and for our generation to solve mathematics. Thank you, and may God bless you. Bye, and all shall be well.